Hi everyone, today I talk about some most important question answers and very most important concept. This concept is linear dependent or linear independent. Okay, Li and Ld. This is topic. It is vector space. Okay, this topic is very most important. So suppose you understand first definitions a set. Okay, of vectors. Okay, are linear dependent. Okay, Ld. If at least if at least one of them can be one of them can be expressed expressed as linear combinations okay others of others, and if there does not exist any linear combinations okay, between between then between them, then okay, they are called linear independent. Okay, so suppose you understand this is c1 alpha 1 plus c2 alpha 2 plus dot plus cn alpha n is equal to theta, and next others k1 x1 plus k2 x2 plus k3 x3 plus dot plus kr xr. Okay, it is linear dependent. Okay, so next example, this example it is very most important. Okay, next linear dependent ld. Okay, let v a vector space be a vector space. Okay, a finite set means alpha 1 alpha 2 dot alpha n. Okay, of a vector of v is to be said to be linear dependent ld. Okay, linear dependent, and there exists if there exists this symbol, it is scalar. Okay, it is scalar a1 a2 dot an belongs to field f. Okay, field of vector f, and not all them 0. Okay, and some of them may be some of them may be 0. Okay, and such that a1 alpha 1 plus a2 alpha 2 plus dot an alpha n is equal to 0. Okay, this is linearly dependent. Next, linearly independent. Okay, let vf vector space be a vector space. Okay, a finite set. Okay, alpha 1 alpha 2 dot alpha n of a vectors of v is said to be okay, linearly independent. Li is said to be it is linearly independent, and if every, always remember, it is every relations of the from a1 alpha 1 plus a2 alpha 2 plus dot plus an alpha n is equal to 0. Okay, and a1 belongs to field f, and 1 less than equals to I less than equals to n. And always remember ai, okay, is equal to 0, while a value it is 0, and for each 1 less than equals to I less than equals to n. Okay, and next, an finite infinite and in an infinite set of vectors of v is said to be okay, is said to be linear, is said to be a linear dependent. dependent is said to be linear dependent, and if it's every and if it's every, okay, finite finite subset is linearly independent, and otherwise it is linearly linearly dependent. Okay, I'll always remember this is all a value. Okay, a1 a2 dot dot an and ai is equal to 0, but this is linear dependent, it is not a value 0. Okay, so next, suppose you understand this linear dependent and linear independent general method and tricky method. So general method, it is rank is equal to number of find rank is equal to number of vectors. Okay, is equal to, it is linear uh, independent. Okay, and next, rank not equals to number of vector. Okay, is equal to linear dependent. And next, determine a not equals to 0, this is linear independent, and determine value a is equal to 0, it is linear determine a not equals to 0, this is linear independent, and determine a is equal to 0, it is linear dependent. Okay, and always remember this topic. So in this time I talk about some more important question answer. Next you clear this topic. The first question, this question is very most important, this question. So this question is very most important. Examine if the set of vectors 2 1 1 1 2 2 1 1 1 is the early dependent in R3. Okay, how to solve this problem? Answer. So let alpha is equal to 2 1 1 and beta is equal to 1 2 2 and gamma is equal to 1 1 and 1. Okay, let use consider the relations. Okay, C1 alpha plus C2 beta plus C2 C3. Okay, gamma is equal to theta, and C1 C2 C3 are a real number. C1 C2 C3 belongs to real number. Okay, and then C1 into alpha means 2 1 1 plus C2 into beta means 1 2 2 and plus C3 gamma into 1 1 1. Okay, is equal to 0 0 0. Next you calculate C1 2 C1 C1 and C1 plus C2 2 C2 and 2 C2 plus C3 C3 and C3 is equal to 0 0 0. Okay, next 2 C1 plus C2 plus C3 is equal to 0. Next, C1 plus 2C2 plus C3 is equal to 0, and next C1 plus 2C2 plus C3 is equal to 0. So next you first two equation solve. Okay. So C1 by minus 1 is equal to C2 by minus 1 and is equal to C3 by 3 is equal to K. Okay. And next C1 is equal to minus K and C2 is equal to minus K and C3 is equal to 3K. Okay. The last equation is also satisfied this is. So K is a arbitrary. K is arbitrary, and there exist, okay, there exist C1, C2 and C3 not all 0. So such that C1 alpha 1, okay, C1 alpha 1 plus C2, C1 alpha 1 plus C2 beta plus C3 gamma is equal to theta. So for example, C is equal to 1, C2 is equal to 1 and C3 is equal to minus 3. Okay. So therefore the set of all vector is a linear dependent. Okay. Because this is determine A is equal to 0. And next it is linear dependent because the set of vectors is a linear dependent. Okay. It is not all 0. Not all 0. Always remember. Okay. Next question. Question number 2. Next question. Next question, this is question is very most important. Shows that the vector alpha 1 is equal to 0 to minus 4, alpha 1 is equal to 0 to minus 4 and alpha 2 is equal to 1 minus 2 and minus 1 and alpha 3 is equal to 1 minus 4 and 3 are linear dependent. Okay. Next question shows that the vector minus 1 2 and 1 3 0 minus 1 and minus 5 4 3 are linear dependent. It is true or not, and it is linear dependent or use solve this problem. Okay. Answer. So this question it is the vectors of a linear dependence if we can find a relations a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3 is equal to 0, and where a1 a2 and a3 are uh, not equals to 0. Okay. Not all 0. Next a1 alpha 1 means 0 2 and minus 4 plus a2 alpha 2 is equal to 1 minus 2 and minus 1. Okay. And plus alpha 3. Okay. plus okay, a3 plus a3 1 minus 4 and 3 is equal to 0 0 0. Next to solve this equation, it is 0 2a1 minus 4a1 plus a2 minus 2a2 and minus a2. Next plus a3 minus 4a3, okay, and 3a3 is equal to 0 0 0. Solve this equation. Okay. So first equation a2 plus a3. Next 2a1 minus 2a2 minus 4a3, and next minus 4a1 minus a2 plus 3a3 is equal to 0 0 0. Next you compare left hand side to right hand side. So this value it is a2 plus a3 is equal to 0, 2a1 minus 2a2 minus 4a3 is equal to 0. Okay. And next minus 4a1 minus a2 plus 3 a3 is equal to 0. And for we get solve this equation, so a1 is equal to 1, a2 is equal to minus 1, and a3 is equal to 1. Okay, as a solution. And so because a1, a2 and a3 are not wall 0, not wall 0. So hence the vectors alpha 1, alpha 2 and alpha 3 are linearly dependent, depend dependent. Okay, so first question answer solved. Next I talk about second question answer. Okay, same to same process you solve this problem. Okay, this question it is a value alpha 1, alpha 2 and this is alpha 3 value. To put it this value, so let a b c be scalars and such that a minus 1 2 and 1 plus b into 3 0 minus 1 these given elements and plus c minus 5 4 and 3 compare 0 0 0 same to same process you solve minus a 2a and a plus 3b 0 and minus b plus minus 5c 4c and 3c is equal to 0 0 0. So next you solve minus a plus 3b minus 5c. Okay, next 2a 0 plus 4c and next okay next next a minus b plus 3c is equal to 0 0 0. Okay, to compare this side minus a plus 3b minus 5c is equal to 0. Next 2a plus 4c is equal to 0. And next a minus b plus 3c is equal to 0. Next you solve this equation. These equations will have non-zero solutions in V3 if the rank of a coefficient matrix is less than 3 the number of unknown a b c, but if the rank of B3 okay. And next the only solutions a is equal to b is equal to c is equal to 0, hence the coefficient matrix okay it is minus 1 2 1 okay this 3 0 minus 1 and minus 5 4 and 3 is equal to this is a is equal to next determine a is equal to minus 1 into 0 plus 4 minus 3 6 minus 4 minus 5 okay it is minus 2 minus 0 is equal to 0, thus the rank of a is less than 3. Okay, the number of unknown is hence the equations will possess a non-zero solutions and this is a is equal to minus 2, b is equal to minus 1 and c is equal to 1. Solutions these equations okay. And next is such a non-zero solution, so hence the vector is linearly dependent. Okay, it is linearly dependent. Minus 10 plus 10 equal to 0. Okay, so it is linearly dependent. Okay, so this question is it is very most important question. Okay, thank you, take care, goodbye. Next I uploaded next part, but last question you note down. This question is very most important. Okay, this question it is 1 2 And next question number 3. Okay, this question is very most important. Test, test, test whether the following vectors, okay, are linearly dependent and linearly independent. Okay, and also find the dimensions and basis. So this 1 minus 1 and 0, 4 minus 3 and 1, and next minus 6 2 2 2, and 9 minus 6 3. Okay, answer. So p is equal to, put it this value. Okay, this is 1 minus 1 and 0, 4 minus 3 1, and minus 6 2 2 2, 9 minus 6 and 3. So this element to 0. And first you understand common this topic. Okay, so determine p is equal to 2 into 3 common. Okay, so 2 into 3 it is 6. So this value 1 minus 1 0, and 4 minus 3 1, and minus 3 1 and 3 minus 2 1. This is 4 by 4 matrix. Okay, and next you row transformations apply. R2 minus 4 R1. Okay, R2, okay, it is R2, R2 minus 4 R1. 4 R1 means this. And next R3 plus 3 R1, and R4 minus 3 R1. So this value it is 6 into 6 into, okay, 6 into 1 minus 1 0, and this value 0 1 1, and 0 4 minus 2 1, and 0 1. Okay, so this is identity. Okay, so this is determined p is equal to 0. So this is linearly dependent. Okay, and the row a is equal to 3 less than number of vectors. Okay, it is linear dependent. And dimension is equal to 3. Okay, dimension is equal to 3. Okay, so thank you, take care, goodbye. Next I uploaded some most important question answer. If you not understand any question answer, so please you comment me. And always remember this topic: a determined value not equals to 0, it is linearly independent, and determined value is equal to 0, it is linearly dependent, and rank is equal to number of vectors is equal to linear independent, and rank not equals to 0. Okay, number of vectors is equal to linear dependent. Okay, so all topic very most important. If you not understand any point, any question, any uh, topic, so please you comment me. Thank you, take care, goodbye. Okay.